Well, next we can find the algebra of complex numbers. In algebra of complex numbers, we usually define how we add, subtract, multiply and even divide two complex numbers. Let Z1 be equal to A1 plus iota B1 and Z2 be equal to A2 plus iota B2, where A1, A2, B1, B2 are all real numbers. Then we define the first thing, that is addition of Z1 and Z2. Z1 plus Z2 will be equal to A1 plus iota B1 plus A2 plus iota B2, that is A1 plus A2 plus iota times B1 plus B2. A1 plus A2 will represent the real part of the Z1 plus Z2 and B1 plus B2 will represent the imaginary part of Z1 plus Z2. Next we go to subtraction of two complex numbers. Z1 minus Z2 will consequently be equal to A1 plus iota B1 minus A2 plus iota B2. A1 minus A2 becomes the real part of Z1 minus Z2 plus iota times B1 minus B2. B1 minus B2 will become the imaginary part of Z1 minus Z2. To find the multiplication of Z1 and Z2, we simply multiply them. Z1 into Z2 becomes A1 plus iota B1 into A2 plus iota B2. We multiply, we get A1 A2 plus iota times A1 B2 plus iota times A2 B1 plus iota square times B1 B2. But iota square is equal to minus 1, so it becomes A1 A2 minus B1 B2 plus iota times A1 B2 plus A2 B1. A1 A2 minus B1 B2 becomes the real part of Z1 Z2 and A1 B2 plus A2 B1 becomes the imaginary part of Z1 Z2. To find the division of two complex numbers, let's find Z1 by Z2, where Z1 is equal to A1 plus iota B1, Z2 is equal to A2 plus iota B2. So, A1 plus iota B1 divided by A2 plus iota B2, we multiply and divide by A2 minus iota B2 and A2 minus iota B2. We get in the numerator A1 A2 plus B1 B2 plus iota times A2 B1 minus A1 B2, knowing the fact that iota square is equal to minus 1. And in the denominator also it becomes A2 square plus B2 square. Taking the real part here, it becomes A1 A2 plus B1 B2 divided by A2 square plus B2 square. That becomes the real part of Z1 by Z2 plus iota times A2 B1 minus A1 B2 divided by A2 square plus B2 square. That becomes the imaginary part of Z1 by Z2. Thus we have found that we can add, subtract, multiply and even divide two complex numbers. Next we define additive inverse and multiplicative inverse of a complex number. First, let Z equal to A plus iota B be a complex number where A and B are real numbers. Then minus Z equals to minus A plus iota times minus B is called the additive inverse of Z. Second, 1 by Z, which is equal to 1 upon A plus iota B, which can be rationalized, that is A minus iota B upon A square plus B square equals A upon A square plus B square plus iota times minus B upon A square plus B square is called the multiplicative inverse of Z.